In this lesson, we are going to cover the second part of indirect measurement. So a little bit of review here. Remember that an angle bisector is a line that bisects an angle. That means that the angle is going to equal each other. So here's what an obtuse angle bisector looks like. That's an obtuse angle, right? Greater than 90. An acute angle bisector, right? A bisector bisects an angle that is less than 90. Here is a straight angle with a bisector. So remember, a straight angle is 180 degrees. And then a right angle bisector is, a right angle has 90 degrees. So it divides that in half. So we're going to cover two more theorems. The first theorem is the proportional angles bisector theorem. It says that if two triangles are similar, then their corresponding angle bisectors have the same ratio as their corresponding sides. So this is very similar to the two other theorems that we were talking about, the proportional altitudes theorem and the proportional medians theorem, right? Only now the line has changed again and we're talking about an angle bisector. Okay, because if you notice here, this is not an altitude because it does not have a 90-degree mark down here telling us that it's 90 degrees. Okay, it's not a median because it's not telling us that NQ equals QP, right? So it's not dividing this line in half. The only thing it's telling us is that this angle equals that angle. So that's how we know it's an angle bisector line. Okay, so if these two triangles are similar, and JH bisects this triangle, MQ bisects this triangle, then we know that JH over MQ can equal JK over MN, okay? We also could say that JH over MQ equals MP, JL over MP. All right, so again, you can pick any of the corresponding sides. It just has to be, one of them has to be the angle bisector. Okay, so here we want to find x for each pair of similar triangles. All right, so here are this pair right here. Now, if you notice, we have the angle bisectors, okay? So what we can say is that 20 over x, right, this angle bisector over that angle bisector, can equal 25 over 15 because these are the corresponding sides that it gave us numbers for. So those would be the numbers that we have to use. So now we're going to take 25 times x, which is 25x, and then we're going to take 20 times 15, which is 300, and then we're going to divide that by 25. So we take 300 divided by 25, and we know that x equals 12. So we know that this line equals 12. Okay, so on this one, it says triangle RTW is similar to ZUY. List the proportions that are true for the pair of similar triangles and explain why. All right, so this is an angle bisector, right? So we would have to use the angle bisector proportions theorem, all right? So what we have to use is the angle bisector. So we know that SW over VY can equal TW over UY. Okay, we could also use the angle bisector again, so SW over VY. Okay, and then we could also say RW over ZY. Okay, and then the last one we could say, again, SW over VY. It's really important. We have to use the angle bisector every time. And then we could say RT over ZU. Okay, so those are the three different types of proportions that we could come up with because of the angle bisector line. Okay, our other theorem that we're going to talk about is the proportional segments theorem. Now, this one is a tad different than the other three theorems that we've been talking about recently because it's still dealing with an angle bisector, okay? So it says that an angle bisector of a triangle divides the opposite side into two segments that have the same ratio as the other two sides. So that's really wordy. What it's saying is that if you have an angle bisector, okay? Then it's saying that RQ, this line right here, over this line, RS, can equal QT over TS. All right, so this side over this side is going to be proportional to this side over that side. So here's an example, right? Here I have an angle bisector, okay? So what I know is that 9 over 20, okay, the top two lines right here, can equal x over 12. Okay, so now I'm going to take 20 times x, which is 20x, and then 9 times 12, which is 108. And then I'm going to divide both of those sides by 20, and I'm going to get that x equals 5.4. Okay, and if I were to plug in 5.4 back up here, right, 9 times 12 is 108, and 20 times 5.4 is also 108. So I know that that's true. I know that x can equal 5.4. All right, on this one, okay, here's your angle bisector up here, right, with angle y. So we're going to compare these two sides, right? We're going to say 24 over 18 equals, okay, since I use 24, I have to use 3x minus 4 right here, over x plus 3. So I'm going to put these in parentheses because we're going to cross multiply here. So remember, when I cross multiply, I have to take 24 times x, which is 24x, and 24 times 3, which is 72. Here, I have to take 18 times 3x, which is 54x, and 18 times negative 4, which is negative 72. Okay, so now I'm going to put all of my letters on one side, all of my numbers on the other side. So I'm going to minus 24x from both sides. That's going to give me 72 equals 30x minus 72. Then I'm going to add 72 to both sides, and that's going to give me 144 equals 30x. So then I'm going to divide 144 by 30, and I'm going to get x equals 4.8. Okay, so that would be my answer. Now to go in and check it, right, I could just plug this in right here. 3 times 4.8 is 14.4, minus 4 is 10.4. So this side, VZ, is 10.4. This side right here, 4.8 plus 3 is 7.8. Now, if I just go plugging back in, right, I would say 24 over 18 needs to equal 10.4 over 7.8. Okay, take 10.4 times 18, which is 187.2, and then 24 times 7.8, which is also 187.2. So you know that that is true. X does equal 4.8. And that is the end of indirect measurement 1.